So today is putting, remember I told you on Monday for mapping, was just getting your toe wet, see how you're doing, making sure that we're all on the same page, make sure there was nothing crazy going on. Today you're starting to get your ankle in, and then Friday you're going to drown in it. So today is actually, because again, I knew this was going to be a light day. Today is going to be all coding, except for one thing, and that's going to be in between. The one thing that you have to worry about in MAPS that's related to the exercise I'm going to have you do here in a few minutes is, what if you try to find a key that is not there? So think about it this way. You've done this before. In an array, what if you try to insert it into a location that's not there? What do you get back? You got a sigfold or something of that nature. Okay? Now, because map is a data structure, and remember, mapping is weird because there really isn't exactly a value. It's all different key names and stuff like that. It's not an index value. So you might have actually a greater chance of finding something that's not there. So the one thing that you're going to have to look up, and not really for right now, but for the next exercise, is how do you find out without having your program blow up if a key is in the mapping or not? That's what your next little item to be after this exercise. So what I want is one of two things. Is you have two little exercises. You only pick one. Because again, I have another one after this that's much more intensive. You pick one, but I want you to pick it with the neighbor that's beside you. So both of you are coding it, and both of you are after the same target. In both of these, I'm not asking you to create classes. I'm not asking you to create anything crazy. Just get the damn thing to work. So that means that you can basically put everything in the driver. That's fine. That doesn't bother me. Okay? So you pick one or the other one. First one, which is create a mapping called states, or the one underneath the program for Morse code. All of the material right now is working with a vector, listen to me, is working with a map with a single key and a single value. Now remember, on Monday we got up to that and we got into a single key, which it always will be, and a vector of values. We are not doing that yet. That'll be the next one. This one is just meant to be a warm-up. It's not meant to be complicated. You're going to make it complicated. All I want is for the damn thing to work. That's it. Capiche? So, with you and your neighbor, and I'm going to be moving some other people because they can't follow my instructions, pick one, get to work. Go and get started, please. And figuring out the answer for that, I don't want you going through Stack Overflow. Here's what I do want you going to, is C++.com. So, in C++.com, how you would figure this out is go to Maps, and then check on the find command, and see what it returns if there's an issue. And how you would block that is the validation that you guys went over in 121. So that's what I need you to be working on if you're done your first set of problems. Again, I don't care which one you did, just do one of them. Everybody capisci? I don't want to see anybody watching soccer or whatever here. Once you're done, that's what you should be working on. Yeah, I know. Get to work. All right, let me see your faces. So, a lot of you are done part one. I'm going to move on to part two. But I also want to stop right where it says hash mapping, are they related? So I want you to understand a concept. This is an algorithm that's extremely powerful. And that is using the hashing that we're talking about and the mapping that we've been doing now for the last 3 days. So what I'm going to do is I'm going to share my screen here. So think about this. So I'll give you a little personal story here that all of you can relate to. So give me 1 second here. Come on. Stupid delay. I have a lot of best friends up in New York, in upstate New York. And you know how you're talking to your best friends, you may not use the most appropriate words. So when my son starts using my phone, he goes, "Daddy, what word is this?" I got to take the phone away from him quickly. But as you know, when you're typing up words, when you're texting your friends, your mom and dad, whatever, don't the same words keep coming up because you use the same words a lot? And apparently with my best friends, I use the same 4 or 5 words quite often, and absolutely every one of them is derogatory. So how does this work? Is the beautiful part about hashing and mapping working together. Now, do me a quick little favor on Google real quick. How many words are there in the English language? Type it up real quick, real quick. Better not be 10. Actually 3. All right. So I believe, stay with me, this is really important because you can use this for an interview question. Guess you're not getting a job. There's 170,000 words in the English language. Now remember, what does hashing do? I'm not talking about mapping. What does hashing do? All it tries to do is to try to organize all this crap and organize it into buckets. So here's what your cell phone does. Your buckets is 26 letters. What letters start with an A? What letters start with a B? What letters start with a C? And I think you can figure out the rest. Now, think about it. Think of a binary search tree that has to go through 170,000 words. Now, I bet a binary search tree can do it pretty quickly, pretty easily, okay? But if you broke it down first by just the first letter, and by the way, what's the O of N of finding the hash character? It's 1, because you just do a mod of the first character, and that's it. So at the speed of 1, you first break it down into the character. Oops, I really don't want to do that. You first break it down in the character, and then you insert it into a binary search tree. So then that binary search tree is just letters that start with B. Or words, sorry. Words that start with B. How much quicker is that? Is significant. That's why when you're texting things up in Google now, Google Chrome is doing the exact same thing now. If you write emails, it's starting to tell you what things you're probably going to finish it with. That's why it's so fast. Because first, they hash it into buckets of letters. Sometimes it's uppercase and lowercase, sometimes separated. Number 2, then they use a binary search tree. Because remember, in the example that we were using, we were linking it to a vector. Aren't both of these, a binary search tree and a vector, a data structure? Yeah. That's the neat part of being able to hash map your application. Because when you're texting things to your friends, it makes no sense to hash it with index numbers. It really doesn't. It Makes sense, put it with letters, because that's what your strings are. So there's a lot of confusion sometimes about mapping and what's the difference between mapping and hashing. There are still two steps in this. First is getting that first letter, and this example is beautiful. There's your hashing, grabbing the first value, determining where it needs to go. From there on out, that is your mapping. And then, once you map it and put it into the right spot, let's see, I'm trying to think of another word that's not, how about bit? Okay? B is, I know, I did not put the other two letters behind it. I was smart. Okay? Some of you will get that, some of you won't. That's okay. First, I hash it, I get the B. I know where to push it. That's my hash. Now I know where to throw it into my mapping. My mapping then throws it into a binary search tree, and bit would be over here. That's why your cell phones are so fast in getting things set up. It's a mix between a map, a hashing, and a binary search tree. So yesterday, when you guys were linking it to a vector, I hope you understood I could use whatever the heck I want. It doesn't have to be a vector. It could be a linked list. It could be a binary search tree. It could be, God forbid, a display tree. It could be all these different things. But it is a mix of a lot of different data structures and algorithms working together. That's the beautiful part about mapping. So that's where your heads need to go eventually. I can tell you right now, one of your biggest final exam questions is like this. You don't have to code it. You got to draw it out and tell me why you're going to use this. How does this piece solve part of your algorithm? That's going to be one of your biggest questions on your final exam is this. Notice again, no code. You can draw it all out. You can word it all out. Totally up to you, but you got to know what you got to do with the game plan. That's the beautiful part about using hashing, mapping, and from there on out. Okay, here's your last one for, well, what do we got, like 20 minutes left? That's fine. Or no, sorry, 9 minutes left. Not mistaken. No, I got 20. Okay, never mind, sweet. Sorry, I thought this said a 4. I'm getting old. So all the instructions are right there. But remember the stem leaf diagram I had you guys draw last class? You're implementing it this time. You're doing basically a hash map, meaning you're chopping off that first number from the temperature. Maybe it's a 7, maybe it's a 6, making sure a key is there or not. If it's not, add it, then add the temperature to the vector. So that's what you're doing for this last question. Again, you do not need to make any big classes for it. Just create a driver for it. Just get the damn thing to work. That's all I'm after. By the way, I already give you code to read in from a file. That's already done. And I give you the data so you can see it as well. So I already have part of your project running. You already can get all the data. It's just how do you get the data and shove it into a hash map is the key. That's what I want you working on right now. If you're not done with the first one, fine. I want you to start working on this because this could show up on your project number 4. So that's why I haven't decided yet. So not this question, but something very close to it. Extremely close to it. So get to work.